Continuing lesson 5.2, if we look at page 261, the try it underneath example 3, Kirsty ran 24 laps in a charity run and then walked 0.2 of a kilometer to the presentation table. Total distance Kirsty traveled was 29.6 kilometers. And the question is, what was the distance of each lap? And explain how you solved the problem. This problem's not asking us specifically, it does not say write and solve an equation, but there will be problems that will specifically say write and solve an equation. So for that reason, that's what we're going to do, even though they don't tell us we have to do it that way, just so we can get some more practice on doing the writing and solving equations. So we have a couple of options for writing our equation. One option we could look at basically the amount of laps that she ran plus the amount that she walked is 29.6 kilometers. So she ran 24 laps, so we should probably, I guess, define our variable, but if we have, if you want to do D for distance that she ran each lap, or L for laps, amount that she ran for one lap, whichever one you want to do there. So that's the amount she ran altogether. And then she walked 0.2 of a kilometer, and then that's equal to 29.6 kilometers altogether. If we go ahead and solve this, and then I'll mention another way you could do this problem. So if we were solving this, the first thing, we would try to get our variable term by itself. They're adding 0.2, so we could subtract 0.2. Make sure you line your decimals up. Since they are multiplying by 24, we'll divide by 24. And when you divide that out, you should get 1.225. So 1 and 225 thousandths kilometers for each lap. Like I said, that's one way we can do the problem. Another option you have and this might be, if you were going to work it out and didn't have to write an equation, this might be your thought process. I'm going to take the total distance minus how much she walked, and that would tell me how much she ran, and then I'm going to divide that by 24. So that would be another option, and you'll notice you're basically doing the same steps that we did on the other one. It just looks completely different. So we look at page 262, number 3. Claire has solved the problem. 6p minus 12 equals 72. Says that p equals 14. How can you check to see if Clara is correct? So there are a couple of different options we have here. One option to see if she's correct is to substitute her answer back in the original problem. And this is something you always have an option of doing when you're working problems out. Okay, if you have time, put your answer back in, substitute it back in, and see if it works out or not. So if you work this out, 6 times 14 would be 84. 84 minus 12. I'm putting a question mark here because it's a question of whether these actually are equal or not. And that would be 72, so that works. So that means that she is correct. So that would be basically saying we would substitute 14 for P. Okay. The other option is we could just work the problem out and see what we get. See if we get the same answer or not. So on this problem, if we try to get that variable term by itself, they're subtracting 12, so we can add 12 on both sides. We do the same thing on both sides of the equation, keeps our equation balanced. That'd be 84. And then we can see they're multiplying by 6, so we would need to divide by 6. And when you divide, you would get 14. Okay? So either one of those methods, either substituting or just working the problem out, would work to tell whether she's correct or not. So look at number 5. 4 times the number n added to 3 is 47. So they want us to write an equation and then figure out, actually solve the equation here. So our equation, we could have 4n plus 3 equals 47, or if you had 3 plus 4n equals 47 would work also. So this would be our equation to start out with. So first of all, they are adding 3. So if I want to get that 4n by itself, I would need to subtract 3. Again, doing the same on both sides of the equation keeps my equation balanced. And then they are multiplying. Variables being multiplied by 4. So if we want to find what n is, we need to divide by 4. 4n divided by 4. 4 divided by 4 is 1. 1n is the same as n. And then 44 divided by 4 would be 11. Once again, if you had time, you could substitute that back in the original equation to see if it works or not. And we can see it does work. We know we've got the right answer to this problem. So we're going to look at some problems. Workbook page 63, starting with number 5. Henry hit 3 more than half as many home runs as Jack hit last season. And Henry hit a total of 8 home runs. So we're going to write an equation to find the number of home runs X that Jack hit last season. So this problem might seem a little bit strange at first because we're talking about 2 different people, and so trying to keep that clear in our minds. Really what they're doing in this problem, though, they're giving us 2 different perspectives of how many home runs Henry hit. One of them is comparing to Jack. One of them is actually just telling us how many home runs Henry hit. And then that's going to allow us to figure out how many home runs that Jack hit last season. So if we take this and kind of break it up into pieces, we got 3 more than, we got half as many home runs as Jack hit last season. So half as many as Jack hit last season. Jack hit X last season, so that'd be half X. We want 3 more than that, so plus 3. That's how many Henry hit. Also, we know Henry hit 8 home runs, so that would be then equal to 8. I like this order. We could technically put 3 plus 1/2 X equals 8. I like this order because if they said 3 less than whatever, then we'd have to subtract 3 from that starting amount. So this would be one equation we could do. If we do this equation, first step, we can see there adding means we would need to subtract 3 on both sides, which would be 5, and then we could say they are multiplying, which means we could divide. Good. Okay, when we're dividing, remember dividing fractions, keep, change, reciprocal. Good. Okay. So you work that out would be 10, which means that Jack hit 10 home runs last season. The other method, this is the way I prefer doing the problems personally. The other method is a little bit complex on this problem. You would have to do 8 minus 3 and divide that by 1/2. Or I guess a third option would be, you could say, if you did 8 minus 3, get that answer and then multiply it by 2, would be doing the same thing. So different ways to do it. Like I said, the first way is kind of the method I prefer, but as long as you have an equation that you can work it out and get 10, any of those three options there would work. Look at number 6. Sarah saved $12.75 every week for a number of weeks W, and she received an additional $25 during the last week in which she saved money, and they want us to find the number of weeks W for which Sarah had saved money if she has $114.25 now. Okay, and it does specifically say on this problem, some of them haven't, but this one specifically says write and solve an equation. So we have to write and solve an equation in order to get our answer on this problem. So one equation we could write for this problem, $12.75 a week for W weeks. So $12.75 times W, that would be how much she saved during those weeks. And then plus the additional $25 gives her a total of $114.25. Okay. Again, there's another equation we could write, but this would be, I would consider this the more common equation for us to write for this problem, maybe. And understand, if you're not writing the equations this way, that's fine, but you are going to have to know how to solve the problems this way. Some of the stuff, even maybe just going to, they might just give you this equation and say solve for W. So just make sure, even though if you like the other method, make sure you know how to do this and solve this out also. So to solve, first step, we're trying to get that variable part by itself. So you can see there, adding 25, we need to subtract 25. When you do that, make sure you line up your decimals. This is like $25. Don't treat it like 25 cents. And when you subtract those, so that'd be 12.75 W equals 89.25. And then at that point they are multiplying, so we would need to divide by the $12.75. And when you divide that out, you should get 7. Which means she saved for 7 weeks. Once again, if you had time, you could work that out. 1275 times 7, get that answer, add 25, and you'll get 114.25, which confirms that we have the right answer for this problem. Number 7, in the year 2000, the number of hazardous waste sites in state X was 8 less than twice the number of hazardous waste sites in state Y. And suppose there were 34 such sites in state X. We're going to write and solve an equation to find the number of hazardous waste sites in state Y, which is N, in the year 2000. I'm not sure why they didn't choose Y, but anyway, they're choosing N for the number of waste sites in state Y. So on this one, if we kind of piece this together, so twice the number of hazardous waste sites in state Y, that would be 2N. And then we want 8 less than that. So we're going to take 2N minus 8. And that's in state X. How many we had? They also tell us in state X there were 34. So that is equal to 34. This is kind of like our home run problem we did earlier. Once we get that set up, they're subtracting, so we would need to add 8. And then they're multiplying, so we'd need to divide by 2. And we would get that there are 21 of these sites in state Y. Another way of doing this, kind of working backwards here, you could do quantity 34 plus 8 divided by 2. And you'll get the same answer that way as well. Look at number 10. Each of 5 friends has X action figures in his or her collection. And each friend buys 11 more action figures. And now they have a total of 120 action figures. So they want us to write an equation that models this problem. So 5 friends, each has X action figures. That means 5X action figures. And then each of them buys 11 more. Here we have to be careful. Each of them is buying 11 more. That means 5 people are each buying 11 figures. So we would do 5 times 11. And then that's giving us a total of 120. So if you do this, 5 times 11 is 55. That's the new action figures that they bought. And then they're adding, so we can subtract 55. And then they're multiplying, so we can divide by 5. And that would give us 13. A similar approach we could have started out. We could have done 5 times the quantity, X plus 11. We could say each of them, after they bought 11, would have X plus 11, and then you'd distribute. And again, another way you could do that as well would be 120 minus 11 times 5, and then divided by 5 would be another option. Number 11, in 1 month, Jason earns $32.50 less than twice the amount Kevin earns. And Jason earns $212.50. Write and solve an algebraic equation to show how to find the amount that Kevin earns. So we can kind of break this apart again. So twice the amount Kevin earns is actually what I'm going to start with. Probably the first thing we should do here is defining our variable. So let K represent the amount Kevin earns. So twice the amount Kevin earns would be 2 times K. We want $32.50 less than that. So we're starting with the 2K. We're going to subtract $32.50 from that, and that's how much Jason earns. They also tell us Jason earns $212.50, so those two things are equal to each other. So once we have that equation set up, you can see they're subtracting. Means we need to add $32.50. And then divide by 2. Which would be $122.50 that Kevin earns. And again, we could think through the process. If we double that, we take $32.50 less than that, we should get $212.50 that Jason earned. So this gives you an idea about solving two-step equations.